expression. These are the example, two simple examples that we discussed, that we checked the last class, the end of the last class. So for example, in the query 1, we took the name and address of all employees who work for the research department. This is the query that you are going to use in your database application. This is the represented by the plain English. Okay, so our goal is to convert this the plain in English to the relational algebra expression. So which means we are going to use the relational algebra operation such as the selection and the projection and rename, and also we have a row and some set operation. That is a union, intersection, minus, and sometimes division. And also we have learned the join operation. Join operation is actually same as the Cartesian product plus, this is not the operation, the selection. Okay, selection condition. And there are different types of the join operation. Natural join, you don't have to pay attention too much that there is natural join, but there is. And also we have the left outer join, right outer join, and full outer join, and so on. So these are the relational operation. It's not that much. So using such operation, actually we can access the most of the data stored at the relational database model. That is one of the benefits of using relational database, the management system, because it's so simple, and using the less than 10 operation, we can do whatever we want. It's so simple to learn. So, for example, the first one, retrieve the name and address of all employees. So, you need to find first the relation where the data is stored, where you can actually find the data. We don't know how to yet, but the first you should know which the table, which relation you are going to need to access. First, the employee, because we are going to access the name and address of the employee. So which means we need to access the employee anyway. And also, we need to use the department. Why? Because the research name of department only in the department relation. Okay? So there are two relations that you are going to access. Basically, when you access the n number of the relations, for example, in this case, 2, you should have the n minus 1 join operation. Okay, so which means because this is an employee and this is a department and sometimes this is a project. Okay, so to access data from the 3 sources, 3 tables, 3 relations, you need to connect to them using join operation. So how many join operation? 2 join operation. Which means when you access n, the tables, it's the same in the SQL that we are going to discuss today. And eventually, whenever you are using the SQL database language, if you find the 5 table you need to access, you should have 4 join condition. So which means the n minus 1. So join condition you should have. For example, in this case we have 1 join operation with the join condition. So what if we have less than n minus 1 join operation? So for example, I need to access the 3 tables, but I have only 1 join operation. Is that the error? No, it's not the error. Okay, there's no syntax error, but it will cause, it will make what? Cartesian product later. Okay, we will see later in the SQL. So for example, if we omit this part, but in your SQL, if you implement this, that is actually Cartesian product. So we will see later. Okay, so in this case, we can use such a join operation, and also we need to find the join condition. Join condition mostly from referential constraint, referential intuitive constraint. In other words, a foreign key constraint between 2 relations. So in this case, actually the D number in employee, the refer the D number in department table. So we can use such a foreign key. Otherwise, it doesn't make sense to the connect to use the two the attribute. They are not related. So there's no meaning. It doesn't make sense. So because of that, we need to use such a referential integrity constraint to connect the two tables. Then properly we can apply the select condition. For example, here the only research department, and also if the statement requirement limit the list of attributes, we can use the project operation. Also, it doesn't matter whether you combine all together the relational expression or separate using the rename. Okay, sometimes it's much easier to understand. Or it depends on your preference. For example, in this case, we can use the department join with the employee and join condition. Then select the D name. It's a research department. Then apply the projection. It will be one. Okay, but you can separate by the operation. So it's up to you. So that means there are many possible solutions in terms of a relational expression. Okay? So for example, when you are taking the exam, so when I ask the same question, there are different the ways of answer for the same question, so it makes sense. As long as the output is the same, then you will get the credit. That is the same thing in the real project, in your classroom project, or even after graduate, you join any database project. So it's the same thing. There are different ways of accessing the data. Okay. The problem is which one is the fastest one. Okay. Just like as if you are traveling to somewhere, so you consider this way, the flight or the driving yourself. Sometimes you need to consider time. You need to consider the cost. Okay. It's the same thing in the database. So we will discuss such a problem in query optimization. Okay, that is the relational, the algebra and relational algebra expression. Any question? So we will see more example while we are doing SQL. Because the SQL itself is just based on the relational algebra, so we will see more example of that. Also, the output of your relational algebra expression can be represented by such a query tree. This is called the query tree. So we can understand how we can access the data. First, we are going to access the department and limit by the D-name research and join with the employee table with the join condition. Then finally, we project first name, last name, and address only. So this is the way of accessing. This is the route to access the data. For better understanding, we can use such a query tree. Okay. For example, in this case, we'd like to implement such a for every project located in Stafford, retrieve the project number, the controlling department number, and the department manager last name. So first, why don't we make the relational algebra expression here? What table, what relation do we need to access in this query? So project location, Stafford, right? So where can you get such a data?
Project table.
Project. So we need to access the project. And what else? Also, department managers. Where can you know who is the manager or not? Department. Is that manager social security number is the only way whether this employee is the manager or not. So department. And also we need last name, address, and birthday. Where can you get the last name of employee?
Employee table.
Say employee. So we need to access employee. So we need to access the three relation. How many join?
To join.
To join the operation. There are different ways to join. So you can join this way, or you can join this and this. Okay. However, in this case, project and employee, they are connected to use the works one. So we need to access one more table, one more relation, works one. So this is not a good way. So for example, when you travel to New York, do you want to go to the Boston, then the New York? No, nobody wants. You want to go to directly to New York, Manhattan. So which means we can join this one and this one. Okay. So then we can start from the Stratford. Stratford is the name of a project. So why don't we? Project is a selection. Okay. Project selection, P name, P location is a Stratford. Stafford. Stratford. Then it's a project Stratford. We can say it. Then retrieve the project number. We need to know the controlling department. Their manager, right? So how can we do that? We can join this one with the department. What is the referential integrity constraint between project and department? We have from the project to the controlling department. Okay, so P project, the D num should be same as D number. Okay, why don't you keep your mind the relational schema diagram? I'm not going to show every time as at the beginning of the semester, we are going to use basically two basic database, company database and university database, so you should be familiar with that. So join, then this is the department and project. Each project is a Stratford, located in the Stratford. There might be several departments, we don't know how many. Okay, but anyway, output is this one. Then we want department manager's last name and address. So which means we need to join this table, this relation, the employee. How can we join?
To the assistant. Manager's assistant.
Because we need only the department managers. Okay? Department manager's last name, so MGR SSM is equal to SSM in employee. Okay? Then this one is the employee, actually department, the manager. Department managers, whose project is in the Stratford. This name can be whatever you want, as long as you can recognize, because this name will be used for temporary. Okay? Then, do we need all this information? No. Department number, the retrieve project number. So which means project number, okay, and department number, and manager's last name, N name, and address, and birth date. Of what? So this one. Then this is a final result. Another way of representing exactly the same thing of this one is you can actually join directly the DPT with the employee using manager. SSN is the SSN. Then join with what? Project. And project, the D num is the same as D number. Then selection, the P location is the Stratford. Then project. Then final out. It doesn't matter. And also you can change the order. I'd like to start from the disjoint, then okay. So as long as output is the same, so it is correct. However, different thing is
Time.
performance, speed. So we will see such a difference later. So using this one, this is the same as this. Actually, I try to follow this step. So from you can access the project and then the selection and join with the department and join with this one and apply the project operation. So using the query tree, it's much easier to understand how we are going to access the data. So this query tree will be used for query processor. So query processor, when a user submit, later we will learn the SQL of this one. SQL will be converted into relational algebra. And relational algebra is converted to the query tree. Then using the query tree, we try to find the fastest way to access the data. So because of that, relational algebra is good for what? Query processing. Why? Because relational algebra show how to access the data. It's kind of your schedule or plan to the travel somewhere. Okay? It directly shows takes this one project and go to and join, and so you can clearly see how to access the route of you're accessing the data. So most of the DBMS use relational database management system use relational algebra for query processing. Okay, and also we can optimize. We can find best the travel plan. So by changing the query tree, we will see later. Okay. There is another way to represent our query that is called the relational calculus. Relational calculus means, so it is based on the set theory. So what is this one? It's a set. It's an integer, positive integer. Okay? Or natural number. This is a set of natural number. Is there any other way to represent this natural number set n using the set theory notation? What about this one? Right? Have you ever learned that this? I think that this is a basic question of your elementary math. So whether they are the same, or why don't you use the different notation? Okay, you can list up the element, or you can give x bar x what? Condition. Exactly same thing. So when we access the data, instead of the list of the operation of the relational algebra expression, using the relational algebra expression, in relational calculus, we are going to focus on such a condition. Then we'd like to see whether output is the correct. So for example, so notation is like this one. T is the tuple. We'd like to access the specific tuple with this condition. So for example here, to find the first and last name of all employees whose salary is above 5,000. Okay? How can we represent this query using the relational algebra? Using select condition, salary is bigger than 50K from employee. And that's the result. Oh, we need to not result yet, temporary. Then we project temporary last name and first name. Either we can change the order. First, we can limit the project, the attribute, then apply the select condition. So we can clearly see which operation will be applied first. However, in relational calculus, it directly shows we need first name and last name such that condition. What is the condition? From employee, salary is bigger than 50K. It focuses on only condition. It focuses on only the output result. Okay? So, query optimizer, output is the same. It's a different notation. But query optimizer itself, query processor use relational algebra rather than relational calculus. Because the relational calculus does not show how to access the data detail, only focus on such a condition. Okay, so this is the relational calculus. So, have you ever seen this one before? It's a select from where? Where did you use this statement? In the database. This is the SQL. Very popular, very famous, very well known. The SQL statement when you access the data. So, we learn select condition. This select condition, selection is going to where? Condition in where? We limit the tuples. What about the projection? We limit attribute, specific attribute. So it's going to list of attribute. And rename. Rename is not mentioned here detail, but it is like the S. You can rename. And also you can rename the table name or relation name here. So this rename implemented here and here. And set operation, you can combine two select from where close. You can apply over here between two SQL. Okay? And also join. Join is the condition in where close. It's a join condition. And all of these are here, join condition. So SQL is nothing but high-level language, program language. Relational algebra and relational algebra expression and relational calculus is not the language. So program language means it's the interface between user and computer. So using instruction, using high-level language, that high-level language is converted, compiled to the machine code, in other words, the instruction, then the computer processor can process the data and information. It's an interface, it's a language like because we are using common language, you can understand what I'm lecturing here, okay? But what about, can you understand what I'm thinking right now? No. Until I express my idea or what I'm doing, you cannot understand. So relational algebra is kind of my thinking, the process, or the idea, or the structure in my mind. Okay? But I need to express my idea using language. That is the SQL. So SQL is nothing but interface to order your idea. Why don't you access the employee whose salary is 50 higher than 50K? That is idea, that is a relational algebra. Then using this SQL is nothing but language. Okay, so which means if you understand fully relational algebra and expression or calculus, this is just converting your idea to this one. Okay, so running SQL is not very difficult. It's not very critical. If you understand the relational algebra fundamentally, you are kind of philosophy. Okay? So that is the method to access data. Then this is just the expression, your idea. So, however, anyway, we are going to use the computer stuff, right? So which means computer can understand these languages. So next chapter, we will learn how to use such a language, which is called structured query language. It's only for SQL is not general language term. Okay, it's only for database language. Specifically, it's a relational database language. It's called the SQL. What about the network database? What about the object-oriented database? They don't use. They are not using the SQL. They cannot use because it's totally different language. Okay. However, because of the popularity of SQL, sometimes people say it's an OQL, Object Query Language. Or something QL because of the popularity. That doesn't mean, however, that doesn't mean the OQL or something QL, something SQL-like the language is the same as this one. No, they are totally different. The SQL is only for relational database model, including Oracle, Informix, MySQL, and Sybase. So those DBMS use the SQL. So next chapter we will see how to use the SQL based on our relational algebra. Any question? Okay, finally, we are going to use. I'm going to skip the details of the relational calculus because not many the DBMS use the relational calculus directly. Most of them use the relational algebra. Oh, this is your homework. Okay, using the company database. Why don't you make for your practice of the relational algebra and its expression? Okay, there are 6 queries in English. Why don't you make your relational algebra expression or list of relational operation? So these are the 6 query. So by Wednesday, too early. So next week, by next week, the Monday, 1 week. Okay. So same thing, using the handwriting. I already caught the cover of the copied submission. It's automatically 0 mark. And not only just your submission, entire the homework will be 0 mark. So if you are caught by the GA and me as cheating, so please don't waste your time to copy others. Okay, just try to solve the problem by yourself. Okay, that helps your practice. So 6 questions and submit the next week, the Monday. Then finally, the SQL part. This is the history, very brief history of the SQL. Okay, so do you know why the database language is much easier than the other languages? What about the object-oriented languages? Java is the only object-oriented language? There are a lot, like .NET environment and many. What about the C language or C? There are a lot of variation of the such language, programming language. However, database, first, as I now introduced many times, relational model was introduced, proposed by Dr. E.F. Coate from IBM T.J. Watson Center. So actually, IBM T.J. Watson Center is located in the White Plain. White Plain is just next to the Connecticut. Okay, so if you drive along the Med Parkway, okay, I forgot the number of exit, but you can see the right-hand side, the White Plain. Then it's just a 10-15 minute driving distance from there. From here is 45. So one of T.J. Watson Center is named, followed by the very famous researcher from IBM, so T.J. Watson. And mostly it's one of the biggest research center worldwide, especially for the database or the data information. So recently it's very well known for what?
SQL processing language.
Watson computer.
Watson.
So have you ever heard about Watson computer? It's a supercomputer and the most intelligent computer. Actually, the Jeopardy, there is a quiz program. So one of the famous guy who won the 50-something game straight, but the Watson computer actually beat the human being. So that is used for the commercial purpose right now. It's mostly somebody say intelligent, actually based on the big data analysis. Anyway, so from the T.J. Watson Center, Dr. E.F. Coate proposed the relational model at the time first. is 69, and 1970 is published. So, however, unfortunately, IBM decided not to proceed the commercialization of the relational, the database management system at the time. So it was called the System R project, but it's stopped by the IBM. Then IBM decided to support what? Hierarchical database and IMS database, their own database. Because not many people at the time, 1970, used such a relational model. So that, including the Dr. E.F. Code and his colleague, quit job, then make the company, and developed next version, and finally in early 80 or the end of 70, I cannot remember the exact year, but it's early 80 probably. They finally launched the commercial, the relational database management system, which is called Oracle. So it's a version 6. Actually, Oracle is from the IBM, the people. But then, because of the popularity of the personal computer in 1980 and the internet is everywhere, so our system environment, computing environment was changing from the centralized system to the downsizing. What 2-tier system, 3-tier system. Then we'd like to use the open platform, not IBM main platform. Open platform means the Unix or Linux, the architecture we adapt. Because of that, relational database is very, very popular, and it's the first market share DBMS model. Then IBM realized to catch up that Oracle product, then that is called IBM DB2. Then still it's the second. Even though IBM merged with the Informix and tried to merge the database market, but still first market share is Oracle, then followed by the IBM, and also third one is the SQL Server. SQL Server, you know, the MySQL, it was open source, the DBMS, Relational Database Management System, but it's merged to the Oracle. Right now it's the commercial, it's the irony. Anyway, but nowadays the Oracle is the most market share, it's almost half, and IBM is a group of medium or small size server or the company, and the Microsoft, the SQL Server is good for Microsoft family product, okay, or the NT environment. So that is the main problem of the relational model and relational database market, because these big three, they share the big pie, okay? However, they don't want to share their pie with other small company or new technology, which means everybody knows relational model